So remember, the first step in solving a differential equation is to separate, then you integrate, just like immigrants, right? So I've got one fraction on the left, one fraction on the right, an equal sign in the middle. So I could cross multiply, and if I cross multiply, I get cosine y dy is equal to 4x dx. So first you separate, and luckily this cross multiplying helped me to separate. Then you integrate. So what I'm going to do is integrate both sides. So the integral of cosine y is actually sine y plus c. The integral of 4x is actually 2x squared plus c2. Okay, remember that's plus 1 divided by 2. And I have one c on this side that I don't know what the c is. I have one c on this side, I don't know what the c is. So I can combine them to one c that I don't know what the c is. So first you separate, then you integrate. Sometimes you exponentiate, and that's only if I have an ln of y, because to get this y out, I'm going to have to e both sides. But this isn't an ln of y, so I don't have to exponentiate. Exponentiating is not going to help take this y out. So then I'm going to either solve for c or solve for y. And it doesn't matter which one I do first. Let me go ahead and solve for c. I notice that this right here is an initial condition, and the initial condition helps me to solve for c. So what I'm going to do is everywhere that there's a y, I'm going to put in a 0, and everywhere there's an x, I'm going to put in a 1. So 1 squared, remember exponents for multiplication, 1 squared is going to be 1. So this gives me c is equal to negative 2. So I cross out the c here, and that becomes plus negative 2. All right, so that's my new equation here. Sine y is equal to 2x squared minus 2. So I've already solved for c, and now I need to solve for y. All right, so what I need to do is get this y out of this sine function. The inverse of sine is actually arc sine, or inverse sine. So what I do is I inverse sine both sides. So if I do that on the left, I get y equals, and on the right, I get inverse sine the quantity 2x minus 2. And this is a great answer. It's also the right answer. And another way to write this, of course, if you know, would also be the arc sine of 2x squared minus 2. Inverse sine is arc sine. Okay, let's go ahead and start our lesson for today. And that lesson is doing word problems. So start with example 1 here. It says the number of bacteria in a culture increases from 600 to 1800 in 2 hours. Assuming that the rate of increase is directly proportional to the number of bacteria present, find two things. One, the formula for the number of bacteria at time t, and then finally the number of bacteria at the end of 4 hours. So the easiest way to do this is actually look at our calculus talk. So we know that initial at time 0, that the number of bacteria, so I'll just call that b, that b equals 600. And at time 2, the number b is 1800. So actually what we have here is two initial conditions, I guess. This one here is going to help us find c, and the second initial condition is going to help us find k. We're going to have a k constant here because of this proportion word here. This is assume that the rate of increasing, so that's the rate of increase in bacteria. So the number of bacteria is increasing with respect to time. So when they say the rate of increasing, they're actually talking about dB dt means equals directly proportional. That means I put a proportionality constant k to the number of bacteria present. So the number of bacteria present is b. So we've set up the formula here based on all these words. It wasn't easy, but you'll see this again and again, this type of problem, and you'll just use your words to set up your calculus talk. So first we want to find a formula for the number of bacteria at time t. So we're looking at b of t equals something. And so basically they're just saying find y, okay? And so this is your y here, your dy or your db right here. So remember, first you separate. So I'm going to divide both sides by b, and I'm going to multiply both sides by dt. So first you separate all the y values over here, all the x values and everything else is over here. Then you integrate, so I'm going to integrate both sides. Okay, this one's a little bit easier if I change it to 1 over b db maybe. And this is, I can put the k in the inside or outside, doesn't matter. Okay, on this side, this is the same problem. Okay, make sure you understand. This right here is the same problem as 1 over x dx. This is really the same problem. Okay, so the integral of 1 over x is ln of x, right? So this one here is going to be ln of b, ln of b. Okay, and this is going to be the integral of k. So remember, k is some number. So what if k were 3? Then wouldn't that be 3t plus c? What if k were 6? Wouldn't that be 6t plus c? So here my k is k. So this would be kt plus c. And of course there's a plus c over here. Okay, but we're just going to combine that with the c on the right side. All right, so first you separate, then you integrate. Sometimes you exponentiate. Do I need to exponentiate here? Yes, I do. Okay, so I'm going to exponentiate, and the way I do that is I e both sides. Okay, and if you tree a log, what happens is the cat falls out, and we talked about yesterday that in these problems the absolute value falls out too. And this becomes kt plus c. Now we e the whole side, not just the kt, but the whole side, so please make sure we record all of that. And then we also know that b is equal to ekt times ec, right? This is exponential properties, and turns out this ec is really just some other c. So you can rewrite this as c-e-k-t, and to be accurate, I'll go back and say, you know, these are all c1s, and then this is a different c. This c here represents e to the c1. I don't know if AP will be that particular or not on that, but you really want this to be the c right here in front of the ekt. All right, so first you separate, then you integrate, sometimes you exponentiate, and then you solve for c and for y. I've actually solved for y already, so now I just need to solve for c. In this problem, I actually also need to solve for k. So I'm going to use the initial condition here to solve for c, and then the second condition here to solve for k. All right, so to solve for c, that means anytime I plug in a t for 0 and a b at 600, 0, this would be k times 0, which is just 0. Okay, what I get is c is equal to 600. So my equation I know is b equals 600 ekt. All right, and now I need to solve for k. Well, again, my second condition here will help me solve for k. So when b is 1800 and t is 2, okay, this is k times 2, which is really 2k. It's kind of awkward to write k2. Okay, I usually switch it unless it's k9, then I would leave it. So right here, this is 1800 equals 600 e to the 2k. I really want to solve for this k, so what I'm going to do is divide both sides by 600. So this gives me 3 is equal to e2k. I want to bring this k down to the ground, so how do you get rid of this e? You log both sides. So this will give me ln of 3 is equal to 2k, because if you log a tree, the cat falls out. And then finally, I solve for k, so I get k is equal to ln of 3 over 2. Make sure you understand this is not the same, okay, it's not the same as ln of 3 over 2. That's something completely different, so please make sure your algebra is good here. And once I know what k is, I can plug that right back into, I guess, the equation that I know what b is right here. I know b is equal to 600 EKT, but I also know what k represents. So this is the same as saying 600 E. Okay, my k is ln of 3 over 2 times t. Okay, and this is the equation. If I had a calculator, I would just plug in any time here, and I could figure out what the number of bacteria is at any point in time. But I want to show you something kind of cool. This could be rewritten in a way that's a little bit more manageable, and that is I can split this right here into ln of 3 times 1/2 t, right? This exponent is really the same thing. And if I do that, okay, what happens is when you tree a log, the cat falls out. But the cat here only belongs to this log, okay, not the times 1/2 t. So what this right here becomes, this part, just this part right here, okay, this becomes 3. I mean, another way to do it is this. Say this is e to the ln of 3. If I take this and put this in parentheses and then move the 1/2 t, just move it down. It's still in the exponent, okay? Remember, power to a power, you just multiply the powers together. So if I multiply these together, I get this up here. And so this in parentheses is actually equal to 3. Okay, so this is 3 times t over 2, essentially. Okay, remember exponents before multiplication though. So anything I plug in for the t, I'm going to do this part first before I multiply by 600. And this makes things a little bit easier. So this actually, I guess, boxed in, let me see, the answers. So the answer is going to be either this right here or this right here. They're both great ways to express the answer to part A here, a formula for the number of bacteria at time t. But if I want to know the number of bacteria at the end of 4 hours, I think the easiest way is actually to get this bottom equation here. So this b equals 600 3 t over 2. Substitute 4 into this equation, right? So that's 3 over times raised to the 4 over 2, which is 2. And remember exponents, so I'm making this is part B. Remember exponents before multiplication, so at time 4, at 4 hours, this will be 600 times 9, so I will have 5,400 bacteria, the number of bacteria. And that's the answer for part B. All right, let's look at another problem. Let's look at this differential equation with this initial condition. So again, we can find C with this initial condition. And the first problem says write an equation for the line tangent to the graph. So this is an equation of a tangent line. What two things do I need if I want an equation of a tangent line? Point and a slope. And I want the equation of the tangent line for the graph of y. So I'm going to put y here so I don't get confused. That means this is y prime. Okay, so I'm just doing this so I don't get confused. I want the equation of the tangent line to the graph of y at x equals 0. So this will be 0, comma, y at 0, whatever this is. So this is y at 0. Oh, do I know what that is? What is the y value when t is 0? It's 91. Okay, so that's given to me right up here. Okay, and I also need to know the slope. So I need to know y prime at the same condition at time 0. Okay, and when time is 0, then I know y is 91. All right, so y prime, but do you see this right here is y prime? So this right here is dy dx at t equals 0 and at y equals 91, because t equals 0 and y equals 91. So this is going to be negative 1/4. Y right there, so it's going to be 91 minus 27. Okay, put this into my calculator. So I have a calculator here. I'm not showing it on the screen. But 91 minus 27 is 64. And if I divide that by 4, I get negative 16 here. All right. So the first question is write an equation for the tangent line. So let's go ahead and write the equation. So the equation is y minus y is equal to the slope times x minus x. And that is a great way to leave your equation. If you wanted to simplify this to just x, that would be completely fine. Not necessarily, but completely fine. And a lot of times people will move that 91 over too. So another way to write this answer, I guess, in slope-intercept form would be y equals negative 16x plus 91. All right, so that was the part A, I guess, of A. But then there's a second part here. It says use this equation to approximate y of 3. So I have an equation for y. So all I do is plug in x equals 3. And this is equal to, let's see, 16 times 3 is 48. So that's negative 48 plus 91, okay, which is 43. All right, so let's go ahead and move to part B here. This is find the second derivative in terms of x and y. Okay, use this to determine if my answer in part A is an underestimate or an overestimate. So remember, this up here was the equation of a tangent line, okay, and I had some sort of something happening at 0, 91. I don't know what, okay, so it kind of helps if you kind of know what things look like. If right here this was 0 and this was 0.091, okay, what I just did with this slope of the tangent line is I drew a tangent line right at this point here. Okay, I drew this as the tangent line. And the slope of this tangent line, well, which is the derivative, but this is the tangent line, and I use it to approximate, you know, this blue curve. And of course, you know, really close to the 0, the approximations would be really good. Far away from the 0 approximations are good if you get lucky. Okay, so over here at 3, they're saying, hey, go approximate at 3. Use this tangent line. What number do you get? And so that's this number 43 here. That's this y value at 3. Okay. What's the actual value? The actual value is down here. This, you know, it'd be down here, but I don't know what the function is, so I can't get the actual value. But do I know if the y value is, or if the approximation is bigger or smaller, or if it's an overestimate or an underestimate? I do, right? Because if the curve right at time 0, and it should be at time 3 too, so maybe I should push this. You know, I should probably move the 3 closer to, you know, closer to the 0. Okay. So the question is this an over approximation or under approximation? If my f was concave down, then my approximation will be an over approximation. If my f is concave up, okay, then my approximation must be an under approximation. So I just need to know if f double prime is positive, right? That would be an underestimate. Or if f double prime is negative, that would be an overestimate. Okay, that's this picture over here. All right, so let me go find out. All right, so I need to get the second derivative. So I go take the derivative of this derivative. So d squared y dx squared equals, I'm going to do the d dx of this. So I guess there's lots of ways to do this. Let me just do the d dx of, let me just distribute this. So it's to be negative 1/4 y plus 27 over 4, right? I think I did that right. So then I'm going to take the d dx of this. So the derivative of this with respect to x, okay, would be negative 1/4. But this is a y, so this would, you need a dy dx plus the derivative of this with respect to x is just 0. Okay, so this is what I get, negative 1/4 times dy dx. But what is dy dx? I know what dy dx is. Dy dx is equal to negative 1/4 y plus 27 over 4, right? Or I mean, I could just even copy this, negative 1/4 y minus 27. Negative 1/4 y minus 27. Either or, same thing. Okay, and so I just need to know, is this positive or negative when I'm at this point, 0, 91. So at x equals 0 and y equals 91, is this number positive or negative? So this would be equal to negative 1/4 times negative 1/4. This would be 91. So 91 minus 27 is 64. So this would be times 64. And then this answer, whatever it is positive, right? Because it's a negative times a positive. Okay, so positive means this is greater than 0. And so if you have a second derivative greater than 0, use what God gave you. You have an upwards curve like this. So the estimate, any tangent line you draw on this, is going to be an underestimate. Okay, if they ask you for the justification, okay, you would say that the justification is because the second derivative, so at that point, is greater than 0. Okay, let's look at the next question. So this question says, find the particular solution to the differential equation. And this is the differential equation. So basically, find the particular solution just means find y. And we talked about this yesterday, but there's a bunch of phrases you need to know that just means find y. One is find the particular solution. Another one is they can just say solve the differential equation. They could be really explicit. They could say, hey, just solve for y. Okay, all these things mean find y. They could also say find the equation of the curve. Okay, so you know, if you have any sort of curve for x, y, you'll just have x's and y's in this equation. Okay, and so they're basically just saying find y. So all of these things mean just solve the differential equation. All right, so remember, the steps to solving a differential equation is first you separate. So here's my equation here. So the first thing I'm going to do is I'm going to divide this by y minus 27 raised to the 2/3, and over here I have negative dx. Okay, now be careful. Of course, I could have moved the negative down here, okay, but that would have made things more complicated for me. Anything that you don't have to move to the left side, don't, because we're eventually going to have to solve for y here, and the more things we put over in this left side, the more complicated it's going to get. Okay, so then what I do is first you separate, then you integrate. So I need to integrate both sides. On this side, I'm going to rewrite in order to integrate, and on this side, let's see, I'm not integrating yet, so let me just leave this side equal like that. On this side, the way you integrate this is you're going to make u equal to y minus 27. Okay, remember this y is usually our x. Okay, so let me change this. Maybe it'll be more helpful. Like this is the integral we usually do, and we'll say u is equal to x minus 27 du dx is equal to 1, dx is equal to du. Then you substitute two things. You substitute your u, you substitute your dx, so this becomes u to the negative 2/3 du. Is this an easy antiderivative or something on my formula sheet? It actually is an easy antiderivative. I'm going to add 1, divide by 1/3, but dividing by 1/3, remember, is the same as multiplying by 3, right? So I'm going to multiply, it will be 3u to the 1/3 plus c. And that's the answer here, although I don't need the c because I'm going to move all the c's to my right side. Let me just rewrite this answer. This will be 3 times x minus 27 raised to the 1/3 plus c. Okay, so let me write this answer up here, 3y, remember this x is really a y, raised to the 1/3. Okay, plus c, I'll just move the plus c over here. And then I also need to get the antiderivative of this right here. Actually, let me leave that there for those of you guys who still need it. So on this side, what is the integral of negative dx? Okay, that's just integral of -1. So that's going to be negative x plus c. All right. So first you separate, then you integrate. Sometimes you exponentiate. I don't need to exponentiate here. And so then I need to solve for c and y. To solve for c, I need an initial condition. So let me go find my initial condition. It's right here. All right, so when x is equal to 0, y is going to be 91. So let me just substitute that in here to solve for c. So 91 minus 27, put that in my calculator, that's 64. So this is actually the cube root of 64 is equal to c. And the cube root of 64 is 4. So c is going to be equal to 12. And so what that means is this equation right here is equal to 12. And this right here would be a great answer. It is a great answer. It's just not the right answer, because not only do we have to solve for c, we have to solve for y. So I'm going to take this, and from here on out, it's just algebra. I'm going to have to solve for y here. Be very careful. Okay, so this is going to be equal to 3 times the square root of y minus 27, not square root, sorry, cube root of y minus 27 equals negative x plus 12. I'm going to divide both sides by 3. That's negative x third plus 4. Get rid of this 3 here. And then I need to cube both sides. So y minus 27 equals, I'm going to switch these. So that's 4 minus x over 3 quantity cubed. And then you need to clean up this y. So it's y equals 4 minus x over 3 quantity cubed plus 27. And that is going to be the right answer. That's solving for y. So that's the first part of this part C. But I also need to use this solution to approximate f of 3. So that just means plug in 3 for all your x's. So that's going to be 4 over minus 3 over 3, which is 1, raised to the third power plus 27. So that's going to be 27 plus 27, which is 54. And that's the answer to the second part of this problem. All right, let's look at example 3. Sometimes the differential equation is not separable. So if I give you a problem that's not separable, like if you look at this, you can try as you might to move the y's to one side and the x's to the other, but there's no way, because if I try to move this y over using real algebra, okay, the dx is still stuck here. And if I move the dx over, like if I multiply everything by dx, okay, what happens is this gets multiplied by dx, and this gets multiplied by dx. There's just no way to move all the y's to one side and all the x's to the other. Okay, so this is an inseparable differential equation. To solve it, you'll take a class in a few years called differential equations, and that'll help you to solve this. But right now, we are not expected to solve differential equations that are not separable. And so if you notice, they actually will never ask you, if they give you a problem that's not separable, they won't ask you to actually separate it, okay, to solve it. So, but they'll ask you other questions. So I just want to point this out so that you don't always think you have to solve for y anytime you have a problem like this. They might be asking you to do other things. So let's look at part A here. Part A says find the second derivative of this. Okay, so to find the second derivative, I'm going to do the d dx of both sides. And so the d dx of this will be 2x dx dx, so that's just 1, minus 1/2. Okay, but this is a y, so I'll have a dy dx. All right, so that's the second derivative right here. I only want it in terms of x's and y's, So I'm going to have to simplify what dy dx is. What is dy dx? Oh, it's right here. This is dy dx right here. So then what I do is I substitute what I know is dy dx right here. And this right here is the second derivative with respect to x. Okay? The next thing I want to do is answer this question here. It says let y be the particular solution. So you don't have to solve for y, but they're saying, hey, you know, y is the particular solution whose graph, so the graph of y, passes through the point negative 2, 8. Okay, so you know this point is on the solution, whatever it is. So again, we don't know what y is, you know, it looks, I don't know what it is, it's y, okay, or f of x. And at this point, negative 2, 8, so let's say this is negative 2, 8 right here. Okay, the question is this a minimum here? Is it a maximum? Or is it neither? And how do you know? And what are they trying to get at? So whenever you see this phrase, not always, but a lot of times, it is what's called the second derivative test. And the second derivative test says, if you go find dy dx at your point, so our point is negative 2, 8, if that is equal to 0, okay, and then you go find the second derivative at that same point, okay, if that is equal to a positive number, all right, then what you know is that your first derivative is 0, so that's going to be, you know, when do you have first derivative 0, right? At mins and maxes, possibly at horizontal tangent lines, okay? But your second derivative is positive, that means you're concave up. So what does that mean at this point is happening? That's a relative min. So that's what the second derivative test says. That if you take the first derivative and you get 0, take the second derivative as positive, then what you have is a relative min. Okay? But, let me see, move this over here. If you take the first derivative at that point, and you get 0, but the second derivative at that point, it's that same point, you have to have some point. So let's say, wherever that point is, you get negative. Well, if the second derivative is negative, what do you know about the picture of f? It's concave down. And if you're concave down, and there's a slope of 0, then what's happening right here? That's a relative max. Okay, you can also use your hands, use what God gave you, to see that when you're concave down, you're like a frown, you have a relative max up here. When you're concave up, you have a relative min. It's opposite of what you think. And then we also know that if the first derivative is not equal to 0, okay, then you have neither a relative min or a relative max, and that's because, you know, if you have a relative min or a relative max, your slope has to be 0 at those points. All right, so if we take a look at this, let's go find dy dx. dy dx at this point here, negative 2, 8, will be equal to 64, negative 2 squared. So that's 4 minus 1/2 times y, which is 8. And do you see that that's 0? So the first derivative at point negative 2, 8 is 0. So now we've narrowed it down to it's either going to be a relative max or a relative min. So let's go find the second derivative. So the second derivative at this point, negative 2, 8, is going to be equal to 2 times, I'm just plugging into this equation, 2 times negative 2 minus 1/2 times x squared, which is 4, minus 1/2 times y, which is 8. Okay, we actually already figured out this right here was dy dx, right? It's this right here. So this is actually 0. And so the answer here is negative. Then this is equal to something negative. This is less than 0. And if your second derivative is negative or less than 0, right, then you have a relative max. So what I have here is a relative max at this point here, negative 2, 8. Okay, so I would say if I were to justify this, I would say there's a relative max. Let me push down a little bit. I'd say there's a relative max at negative 2, 8, and my justification would be the first derivative at that point is equal to 0, and the second derivative at that point is less than 0. And that would be the reason. You can't just say second derivatives test. They actually want you to say what the test, explain the test, like how the test works. All right, let's look at another problem. Notice this actually was not even solving a differential equation problem, so I just wanted to point that out so you don't get confused. Let's look at this problem. It says find the equation for the curve passing through the point 1, 4, which the slope of the curve is 6 times the x-coordinate. So I'm just going to write this out to make sure you understand it. You're trying to solve for, you're trying to solve for y, and you're going through the point 1, 4, and the slope of the curve, so slope of the curve is dy dx, is 6 times x, is what they're saying. And now they're saying solve for y. So first you separate. You actually don't even need to separate this because there's no y on this side. You can just integrate both sides. But I'm going to go ahead and separate so you can see that we could separate also. Okay, so first you separate, then you integrate. The integral of 1 is y plus c. I'm going to move my c to the right side. On this side, if I integrate 6x, it's 3x squared plus c. All right, and this is the answer, except that I want to know what my c is using 1, 4. So everywhere there's a y, I'm going to put in 4. Everywhere there's an x, I'm going to put in 1. So here I get c is equal to 1. And if c is equal to 1, I can just cross this out, put 1. Please do not erase the c ever. Please just cross it out, or you can just rewrite this as y equals 3x squared plus 1. All right, let's look at your last example here. I have the temperature inside a refrigerator is given by this function w, so that's some sort of temperature, and it satisfies this equation, differential equation. W is in degrees Celsius, and T is in hours, and at time 0, I know an initial condition that temperature is 3, or W will be 3. The first problem says write the equation of the tangent line of y equals wt at this point. Okay, so again, if you want the equation of a tangent line, what two things do you need? And I want the graph of w, so I'm going to put w here. And so this y value here would be w at 0. And do I know what that is? Yeah, it's 3. Okay, and the slope will be the slope at that point, 0, 3. Okay, how do I find that slope? It's going to be dw dt, because I have a formula for that, right? And I know what time is. Time is 0. And I know what w is at that time. So w is 3, right? So cosine of 0 is actually 1. So this will give me 3 over 6, which is really 1/2. Okay? I want the equation of a tangent line, so that's going to be y minus y. But my y is called w here, so I'll say w minus 3 is equal to the slope times x minus 0. If I wanted to simplify it, I can write it like that. And if I wanted it in the slope-intercept form, I would write it like that. Okay, all of these are right. Technically, actually, this x is really a t, right? So t plus 3, I guess, if we are going to be careful. Okay, so all the x's were actually t's. Okay, and then use this equation to approximate the temperature at time equals 0.4. So what I'll do is I'll use this equation here and put in time equals 0.4. So this would be 1/2 times 0.4 plus 3. It's kind of hard to do. Actually, if it's a free response, you could actually just leave the answer just like this. I guess if I really wanted to figure it out, I could call this 4/10. And that would be equal to, what's that, 2 over 10 plus 3, which would be 1 over 5 plus 3, which is 3.2. If I wanted to go that far, I really could just, you could totally stop right here if you wanted to, since this is a free response question. Okay, and then finally it says find y, the particular solution to the differential equation, and this here is an initial condition that will help me to find c. So again, this is going to be separating and integrating. They're telling me to find w or y. All right, so first I separate. So here's my differential equation right there. I'm going to multiply both sides by 2. Whoops, no, don't multiply by the 2. Just multiply by the w. Again, remember I told you we're going to solve for w. So if you move that 2 over here, it's just going to be more work later on to move it back. So I'm going to call this w. dw is equal to 3/2 cosine t dt. All right. First you separate, then you integrate. If I integrate this, I get w squared over 2 plus c, but I'm going to move all the c's to my right side. This will be just a coefficient, so pull that coefficient over. I need the integral of cosine t, which is just sine t plus c. Okay, so first you separate, then you integrate. Sometimes you exponentiate. To solve for my w here, do I have an ln of w? No. So now I just need to solve for c and solve for y. So let me solve for c first. I know when time is 0 that w must be 3. That's my initial condition. So this would be 9 over 2 is equal to 3 over 2 sine of 0 plus c. So that gives me c is equal to 9 over 2. And if c is equal to 9 over 2, I can just cross this out right here. And so what I get is w squared. Actually, I can multiply this whole thing by 2. So w squared is equal to 3 sine t plus 9. And so w would actually be equal to plus or minus the square root of 3 sine t plus 9. And that is the answer, but I need to choose the answer that if I plug in 0, I get positive 3, right? So there are two possible answers here. W could equal positive 3 sine t plus 9, or w could equal negative 3 sine t plus 9. Okay. If I plug in 0 here, I would get positive square root of 9, which is 3. If I plug in 0 on this side, I would get w is equal to negative square root of 9, which is negative 3. So which one of these answers gives me 3? It's this answer over here. So the answer is going to be this right here. It would be good to look at how AP grades this problem. So each free response you get 9 points, and so 2 points here is for part A and 5 points is for part B. The 2 points for part A, you get 1 point for getting the tangent line right. So there's the equation of the tangent line. You could write it in any form. You know, I'm pretty sure if you had it something like this, you know, this would still be right. If you had substituted the t for an x, very likely they would still count it right. Okay, as long as there's no x anywhere else. The second point would be if you got this 3.2 right. This one has degrees Celsius, but if they don't say write the units, you don't need to write the units. And then look at part B. Look at how your points are. First you separate, right? Then you integrate. This is solving for C, and this is solving for Y. So you get points for each of these steps, okay, in solving the integral. And if you never put in a C, like if you erase that C, it never shows up, okay, the most points you could get is 3. So always write your C and never erase it, okay? And if you never separate, you don't get any points. Even if you got the right answer, if you never separated, you won't get any points. So that's how AP will grade your paper.